Okay, so we're back, and we were noting that the way that the sex variable appears in the GSS, even though we described it previously as nominal and dichotomous, because it had two categories, it wasn't actually coded as a dichotomous variable needs to be in order to work with it statistically. It was coded as 1 and 2. And so we need to recode this variable or else make a new variable based on it, where males are coded as 1 and females are coded as 0. And that is what is happening in the chunk below. We're making a variable called male. And this is saying that we're making a variable called male for every time the variable sex is a 1, we're going to make male 1. And then everybody else will be a 0. And in this case, the only everybody else there is are the females, right? So we're making a variable male, 0 if you're female, 1 if you're male. Get the frequency and the mean, and then we're going to get a 95% confidence interval. Okay, so let's run that. Ignore the error messages. So true are the people who are male. If you looked at this without the labels, this would be coded as 1 and false would be coded as 0. False are the females. We see that the mean or the proportion of males is 0.44, which matches up with our 44.1%. And then we have a 95% confidence interval for male that goes from 0.44 to 0.45. Okay, so first question, why do you think I named the new variable that I created in the chunk above male? And I'm going to say we named it male because in this variable, anyone with a true or 1 is a male, and anyone with a false or 0 is a female. It makes sense for it to be called male when males are true, right? Interpret the confidence interval that we got, and over here, same kind of interpretation. In this case, we are looking at the proportion of males in the U.S. population. We are 95% confident that the proportion of adult males in America is between 0.44 if we round it, and 0.45. Okay? So now the meat of today and what we will be working on or at-home learning review leading into your final project is comparing groups. Now, I have some wording in here that talks about what happens when we want to compare groups. You don't need to worry about that because I will provide the code for you, but essentially what you need to do is pull out each group and make a confidence interval for that group separately for its dependent variable and then compare. So in this case, I am looking at the proportion of people who are childless, and I'm comparing it by sex. So what is the relationship between sex and having children? And my null hypothesis is that there's no difference between males and females in the proportion who are childless. And my research or alternative hypothesis is that there is a difference between males and females in the proportion childless, that sex does matter for whether one has children or not. Okay, so we have several pieces here. After I run the chunk, I'll explain what we've done and what to look at. Okay, as usual, we had warnings, but we don't need to worry about that. So the first thing I did was pull out the males, and then I made a confidence interval for males for the proportion childless, 95%. And then I did the same thing, but for females. So the output that you see here, this is for males, the top, and the second one is for females. How do we interpret these? Well, we use the same sort of language that we've been using for all of our other interpretations. We are 95% confident that the proportion of childless males in the population is between 0.32 and 0.33. Okay, write an interpretation of the confidence interval around the proportion of childless females. We are 95% confident that the proportion of childless females, set off my warning screen, females in the population, stop it, is between 0.23 and 0.24. The confidence intervals for males and females do not overlap, right? Females go between 23% and 24% childless, whereas males are between 32 and 33% childless. So there is a difference between the two groups. We can reject the null hypothesis that there is no difference between males and females. We can conclude with 95% confidence that the proportion of childless men and women in the population is different. I don't know, the phrasing sounds kind of clunky there. That the proportion of people who are childless in the population, the proportion of people who are childless in the population is different for men and women. We can conclude that sex and childlessness are related. Okay? So that is how you would go about comparing your groups. Now we are looking at an example using a mean, and we're looking at race. So our research question would be, what is the relationship between race and hours of TV? And our null hypothesis would be, there is no relationship between race and the mean hours of TV watched per day. And our alternative hypothesis would be that there is a relationship between race and the mean hours of TV watched per day. Again, don't worry too much about the code. Just notice in this chunk, I'm pulling out the white respondents, and then I'm getting a confidence interval for the mean hours of TV specifically for whites. And then I'm doing the same thing over here. I'm pulling out the others, and I'm getting a confidence interval for TV hours for others. And don't worry about the error messages. And let me just see what's happening over here. Okay, those are just the mean TV hours for each of our three groups. Let's focus on the confidence intervals. First is whites, 2.8 or 2.6 2.79 to 2.84. And for others, it's 2.66 to 2.88. Now, we didn't do it for the third group, which are Black Americans. And so, again, I'll make the code for you. You won't have to do this. But let me just show you here. Just going to add another chunk. I copied that code, and now I'm pasting it here. And I'm separating out Black. And so I'm saying take out everyone who is Black and give me the mean for the Black group for TV hours. Okay, so now when I rerun this chunk, we'll have white, other, and Black in order. Okay. What did it not like? Oh, I see why. I had to specify that this group is called Black. Okay, so in this case, I mistakenly didn't replace that. It was other. So you're making sure you're pulling out whites by using white, other by using other, and Black by using Black, and then getting the confidence intervals for each group. Okay, here we go. Okay, so what is an interpretation here about the confidence intervals? We are 95% confident that the population, mean hours of TV per day for whites is between 2.79 and 2.84. We are 95% confident that the population mean hours of TV per day for others is between 2.67 and 2.88. And finally, we are 95% confident that the population mean hours of TV per day for Blacks is between 3.90 and 4.07. Comparing the three groups, whites and others overlap. You can see that, right? It's these two groups right here. They cover some of the same area. Because they overlap, we can't conclude there's a difference. But when you compare Blacks with each of those two groups, Blacks are different. They have a higher mean hours of TV. Blacks and whites do not overlap, and Blacks and others do not overlap. We can conclude that Blacks and whites and Blacks and others watch different amounts of television in the population, with Blacks having a higher mean hours of TV. However, we cannot conclude that whites and others are different in the population. Our null hypothesis is partially rejected for Blacks compared to the other groups, but we can't reject the null hypothesis when comparing whites and others. Okay? And you want to save and you want to upload to